On this particular, we could have just done this without all the calculations, all right? We could have solved this without all the calculations.
Yeah,
right?
you can say, oh,
Okay.
yeah, because it's shift to the left. You
The only one is the difference.
That is multiple choice.
Right.
In case I give you a short answer, you can do that.
Explain. Okay. All right.
Okay. Now this is actually easy because it's shifted to the left. We haven't used the pKa2 yet. What about we add base? We add strong base.
Let's shift it to
We add strong base, it will shift to the right, then you have to use the pKa2. Let me give you an example. Think about an example. Think about an example. Let's put the... Okay. That's the initial. You'll use the initial pH, initial concentration of the whole thing. And the initial pH is 6.8. Now let me add sodium hydroxide. I give you 1 molar sodium hydroxide. I give you 0.60 milliliter of the strong base. What will happen? Okay, now we calculated this already. Then you need to know how many moles of sodium hydroxide we added to the solution. That is 0.06 moles, right?
Mm-hmm.
We added this strong base to the solution. This will drive the reaction from left to the right to cause more dissociation of the proton. And eventually it will drive it to the rightmost. Okay, this will react with let's start from the A+. We react with the A+. How much it will consume? How much it will consume? Consume all of it. If I use all of this to react with A+, this will become 0 final, right? And it will become this. What about this?
It's going to become plus 0.02, so 0.1.
0.08 plus 0.06.
Oh.
Would it just be 0.02?
Why would it? It can only consume what's available, right?
Yeah, plus 0.02.
Or is this a trick question?
Yeah. This will become 0.
So that's minus 0.02, the other one's plus 0.02.
Yeah, I have a 0.0. Well, this is not correct.
Right.
I need to add more. It doesn't drive it. Okay, let me add 0.2 moles. That will be 200 milliliter. Okay? 2 moles. This will become 0. This will be 0.8. And then you can still consume this one. 0.8, 0.08. Yeah, plus 0.0802. That's correct. Okay. All right, this will be consumed, right?
Yes.
This is consumed. Whatever consumed will initially form 80. Okay? So this will be 0.8 plus 0.02. Okay. Then we still have how much left in the strong base? That is 0.2 minus 0.02, right? We still have this much left for the strong base. Okay. So initially this will be this much, this will be 0. We still added 0.18 moles of sodium hydroxide to the solution. Now to this initial condition, what will happen? this can drive this further right. Okay. That's too much. It will be totally busy. Okay, let me get. Let's go back. Let's go back. Let's go back. It will be totally basic if we add too much strong base. That's not good. Let's still do 0.0 60 mu. 60 mu is good. So that is 0.06 more, right? Okay. So 0.06 more will react with a plus. This will become 0. And then this will become 0.08 plus 0.02. Okay? And at this moment, there's 0 here. But we still have how much left? 0.04, right? More of, we used up 0.02 more of sodium hydroxide to consume, to react with this, to allow this to become 0. And whatever finished here will be added up to this, okay? And then we still have 0.04 more of NaCOH, okay, in the solution. And then this much will continue to react with H0 to form A minus. All right? So how much will be consumed here?
0.04
0.08 plus 0.02 minus
0.04.
0.04, right? Okay.
It's going to create 0.04.
And how much will be formed? How much A minus will be formed?
0.04.
0.04. We added 0.04. Okay? That is 0.04 for A minus. And this is the final concentration of A0. Final concentration of A plus will be 0. Okay. Now we are already in this equilibrium. Let's calculate the pH. pH equals to pKa
Plus
what? pKa1 or pKa2?
2.
pKa2, because we're talking about this equilibrium already. That's pKa2 plus log
A minus over A0, A naught.
A
Minus
minus divided by
A naught.
A0. Okay. And we know that will be log 0.04 divided by the volume. Okay? You can cancel the volume. That will be 0.06 divided by the volume. Right? This is the concentration of the acid, the conjugated base. That will be 4 to the 6. 4 2/3, right? And pKa 2 equals to
9.5.
9.5 plus this.
So it's going to be a negative. So
This is a negative.
so
Very close to
C0.
1 already. So you have calculated, I don't know, I only know log 4.
That's awesome.
I'm not as, I'm not more smart than you. Log 2 to 3, 1.414, whatever. So it's close to 9.5.
Oh, it is, alright. So it's D here.
All right? It's 9.5. Anybody have a calculator? Negative 0.17. Negative 0.17.
9.3.
So the final pH of this solution after we added 1 molar and 60 ml of sodium hydroxide will be
9.33.
9.4. 9.33. Okay? 9.33. That's also true, right? Because we added strong base
Alright.
to shift the equilibrium to more basic solution.
Yeah.
And become more basic. And the pH get increased. Correct? So you remember, you need to go back from the exercise practice. Add strong acid, add more strong base, or start with a strong base, titrate back. So a lot of tricks. I assure you there will be exam questions for this type of question. And either starting with the base or acid, add how much volume of strong base.
Cool.
Okay. Have a good Labor Day weekend.